Hi, in this session I will show you how to increase the expressiveness of your taxonomy. We will especially focus on the difference of taxonomies, custom schemes and ontologies. After this session you will be equipped to create specific relations and use attributes that describe your domain as precisely as you need it for your applications that rely on that knowledge model. We will also go through a couple of concrete examples together that will help you to reproduce the knowledge in your projects. By now we have created taxonomies based on SCOS, which include a set of relations that are embedded in the PoolParty taxonomy tree. The taxonomy is structured as a simple graph through broader and narrower relations and allows to go beyond the hierarchical structure through related concepts. When you extend the SCOS view to advanced, you have some more options to express relations as through exact matching concept, close matching concept. As a user you don't have to bother about the SCOS methodology. You can use it almost intuitively. That's one of the true benefits of SCOS. You can start creating knowledge models without highly advanced knowledge engineering skills. But if you want to apply the taxonomy for advanced machine learning purposes, you might want to become more specific in your knowledge graph. What do I mean with more specific relations? You see here the cocktail John Collins, which has the garnished cherry. John Collins and cherry are concepts that belong to different concept schemes. In SCOS they are related to each other, but now we would like to indicate that the cocktail John Collins has the garnished cherry. And this is where custom schemes and ontologies come into play. When we work with ontologies, we classify concepts more precisely, and we express relations which go beyond SCOS relations. In a SCOS taxonomy, you have structuring elements as concept scheme, top concepts, which are helpful to the taxonomist, but the machine can't read them. It is with ontologies that you introduce classes, and that gets recognized by machines. Before I show you hands-on how to develop this semantic expressiveness, you also need to understand how taxonomies, custom schemes and ontologies play together in PoolParty. We differentiate 3 layers. Imagine the International Bartender Association builds a knowledge model around the world of cocktails that includes basically everything around cocktails. All cocktails, all ingredients, the corresponding recipes, a stakeholder overview as beverage brands, distributors, bar chains, award-winning bartenders, and so on. This ontology is obviously interesting to many stakeholders and applications for reuse, but only partially, and that's why the association has different variations of this master ontology in place, which uses only parts of it. For the association it is essential to manage the master ontology centrally, so that changes get propagated to all custom ontologies. And at the 3rd layer, the taxonomy layer, you apply the custom schemes. In this example, this could mean that a beverage brand wants to offer a recommender application for cocktails and applies a specific custom scheme to its taxonomy that is already in place and needs now to get more specific in its semantic expressiveness. That's why we implemented ontologies as a central hub. It's here that you manage a master ontology that can be applied to multiple projects. To use an ontology, you need to create a custom scheme in PoolParty, and it's here that you can take parts of one or multiple ontologies and customize it for your taxonomy. You create mash-ups of different ontologies in a custom scheme. And if you encounter due to your project learnings that you need to do some changes to your ontology, which is now used distributed, you can do the changes at the ontology layer and it will be propagated to your custom schemes and therefore to your taxonomies. In PoolParty there are different approaches to build these highly specific taxonomies. You can extend relation and attribute types for our ontology library, Or you can import, for example, existing industry ontologies into PoolParty and extend your taxonomy by it. Or you build your own ontology. In this session we will focus on building our own ontology, but in the advanced session I will introduce you to these two other approaches as well. When you create an ontology, there are also three different approaches. You can choose a top-down approach, so you would start with classes and break them down into narrower concepts. Or you would choose a bottom-up approach, so you would detect patterns in concepts and start clustering them then. Whereas in the top-down approach, you would start your taxonomy and ontology considerations with classes as alcoholic beverages, cocktails. In the bottom-up approach, you would come up with these classes as they derive from your available concepts. So here in this case I have a list of wine cocktails, Mimosa, Rose, Spritz, Veneziano, and as I collected them I perhaps realized I have more of them, and so I created the top concept wine cocktails in the next step. In reality, most companies go for a middle-out approach. So you start and continue your work somewhere in between these two approaches. You also change the approaches, as actually knowledge modeling is an iterative process. And now I will show you how to create an ontology directly in PoolParty. But let's wrap up some details about our example first. Let's assume that I already have a taxonomy about the knowledge domain cocktails in place, and now I want to increase the semantic expressiveness of the taxonomy. And I want specifically to relate concepts out of different concept schemes, as I want to express that cocktails have a certain garnish. This means I will introduce classes, and this is where the ontology development starts. And it is a perfect example for a middle-out approach, as I introduce the classes along the way of my knowledge modeling process.
Here we have our taxonomy to be extended by using classes. In order to do that, I'll open the ontology management. Here you see the tree containing the ontologies and custom schemes. Click the button New Ontology on the right to open the dialog. I'll call this new ontology Master or Cocktail Ontology. In the next step, I also have to define the user group the new ontology shall be part of. Assigning a group is mandatory, since only users of the same group as the ontology will be able to edit it. After having created the ontology, you would add classes, relations, and attributes to it. In PoolParty, you have several possibilities to add classes. I will use the first one here. Click on the ontologies node to activate it. On the right, you will see the section that lists these three properties. Clicking here, I can create a class. I will create three classes: alcoholic beverages, cocktail, and garnish. When the dialog opens, you will see that there is a checkbox called "Is a subclass." When creating an ontology that allows for additional relations, it might make sense to use the class cocktail as subclass to alcoholic beverages. At this stage of the knowledge engineering, I may not need the class alcoholic beverages, but at some points, since this is an iterative process, it may make sense to add higher levels right away, since they will be inherited to the subclasses when you create them. Therefore, we recommend that you spend enough time to plan the stage carefully. Now that I have created the two classes, I will create a relation between them. There are several ways to do that too. I will use the nearest one here. Click the node Relations, and on the right, click Create Relation. In this new dialog, I can choose the relation type and enter a name for it. I will call this relation has garnish and use the type directed. I could make this relation a unique one, which means it could only be used once. But since several cocktails can have different types of garnish, I will not activate that option. On the left and right of the relation type, you also can see the no restriction entry. Here you can define the domain and range restriction. I will define cocktail and garnish. This way we can determine which classes can use the relation in combination. It is a quality assurance mechanism which ensures that only these classes can be added to this relation.
So let's speak a little bit about the different relation types. We chose before the directed relation, which goes one way. But what could I do with a symmetric relation? A symmetric relation works both ways. So this could actually work with the few classes we already have in place, because I could indicate that one cocktail is a variant of another cocktail. So this is an example for a symmetric relation. And then we have the inverse relation, and this is definitely something which increases the semantic expressiveness. So before you create an directed relation, think about if you could also express it as an inverse relation. And indeed, I could actually say that the garnish relation from before can be expressed as inverse, because I could add here the relation type is served. And here you see the domain range restrictions and the relation type. So an inverse relation is definitely more expressive than a directed one. So I delete the directed one. But again, it always depends on your use case. So it's not a must to apply inverse relations. Just a recommendation. And then you can also add attributes. So I switch to attributes. I could, for example, indicate that the cocktail is served frozen. And this is a matter of true or false. So I would select the type Boolean, and I have to apply that to a domain which is cocktail. And here I have my domain attribute restriction. I have different kind of types I can use to create these attributes. So for example, if I would like to add the addresses of cocktail bars as an attribute, I would go for a literal, which is a text field. And if I would like to indicate on which day a certain bar was opened, I would choose date. And if it's really about the opening date, it would make sense to select the single use, one value, but perhaps I would like to indicate which cocktails were served on a certain day. Then I would need more values for my attribute date.
Now I want to apply these relations and attributes to my taxonomy. In order to do that, I have to create a custom scheme. I will call it Cocktail Recommender Scheme. My ontology will then be included here. You may also remember that we mentioned earlier that you can create mashups from the ontologies. We will come to that in more depth in the advanced session. So now I will apply this custom scheme here. I click Advanced and from here select a custom scheme and activate it. I then return to my taxonomy tree. Here I will apply the class. In this case, class and concept names correspond, but that is a coincidence. You see that now the concept has inherited the class cocktail and also the class alcoholic beverages we created earlier, since cocktail is a subclass of alcoholic beverages. When we apply the class cocktail on a concept scheme, all top concepts inherit that class as well. But here we can also see a special case in our taxonomy that will make the mashup helpful. Although the top concept sources are ingredients, and the same goes for the top concept sweeteners, yet at the same time fruit are definitely not ingredients. So we will apply the class garnish to the top concept fruit only. Here you can see now that by applying classes to a top concept instead of the concept scheme, only the top concept fruit in this case has that class applied to it. The top concept sources and sweeteners stay as they had been before. Thus, we can refine the taxonomy we already set up with additional properties, as shown before, such as classes and relations between them, to create what is called a knowledge graph.
But in our top concept tree, herbs and spices, I see that there are some single concepts which could be also classified as garnish, for example, mentha. And I'm gonna apply here the custom class garnish as well. So this is the perfect example that within different top concepts and concept schemes, there could be single concepts where some classes make sense to be applied. But you might wonder, how can I keep track which concepts have the class garnish? And for that purpose, you can actually create a collection, so which you can call garnish. And here you could add per drag and drop all the concepts which you would like to have in this collection. So you would of course just create a collection when you need it, and this depends on your use case. Yes, so the moment I classified my concept schemes, my concepts, I get right next to this COS dashboard the custom scheme which I enabled with all the relations and attributes I created. So I know, for example, that John Collins has the garnish cocktail cherry. So I indicate this relation, and when I switch to cocktail cherry, you see the inverse part of the relation is served with a John Collins. Let's go back to John Collins one more time. Here you have this symmetric relation is variant of. So I know that Tom Collins is often very similarly mixed as John Collins. So I draw this relation, and when I go to Tom Collins, you see that it is related to John Collins through the relation is variant of. And here you have the attribute served frozen We said a cocktail can be served frozen, yes or no, true or false, and actually it's served poured over ice, so it's true, and I can indicate this here as well. So before we come to an end of this learning session, I want to speak with you about knowledge modeling, and specifically about when to use attributes and when to use relations. So let's take a closer look at the concept scheme cocktail bars. We have here a collection of cocktail bars in London, for example, and we have an attribute which is called address. So all the cocktail bars have an address. You can create relations only with existing concepts, and attributes you rather use when you have very specific values, as for example thousands of different addresses. It would not make sense to model these addresses, which you can use only once for one cocktail bar, as a concept. That's pretty straightforward. But imagine you have thousands of alcoholic beverages. So you have different vodka brands, and these vodka brands are sold in different kind of bottles, and actually these bottle sizes are standardized across the US and Europe, and perhaps you have 3 different bottle sizes. So you would not like to manually add this bottle size as an attribute. It would rather be handy to model these bottle sizes as concepts and simply relate them through the relation has bottle. And another advantage you have when you create this as a relation is that you can generate lists. So when you go on the concept bottle size, you see the inverse part of the relation is used, and then you see which alcoholic beverage brands are selling their product in this bottle size. Now you know how to extend and tailor suit your taxonomy. You know that in PoolParty we differentiate custom schemes and ontologies. Ontologies are your central hub for your knowledge model. Custom schemes allow you to make mashups out of different ontologies. And you know the workflow, how to enable custom schemes to your taxonomy. So you know that you have to classify your concepts according to the custom schemes you want to use. We also spoke about the different relation types, the directed relation, the symmetric relation, and the inverse relation. And we had a look on different attribute types and a discussion when it makes sense to model something as an attribute and when it is rather useful to model something as a relation. Because knowledge modeling can take different forms, and it is up to your conceptual approach how your knowledge model will look like in the end. There will be an advanced session where we will take a closer look at ontology libraries and also how to create mashups out of different ontologies. And we will speak about some functionalities which will add some more complexity to creating this knowledge model.